Hello, everyone, and welcome to today's webinar. My name is Amber Artrip. I am the Vice President of Marketing here at EnergyCAP, and we are so excited today to share with you about our newest solution, which is Wattics, real-time energy analytics, and how our customers can find value from our latest solution. We have over 200 folks on the line today, so thank you all for sharing your time with us. And we want to just cover a few housekeeping items before we get started. This webinar is being recorded, so everyone who has registered for the webinar will be receiving a link to the recording within 24 hours of the webinar. If you have any questions, please use the Q&A button at the bottom of your Zoom screen and to submit your question to us. We will get to as many questions as we can at the end of the presentation. If we're not able to get to your question, we'll have someone follow up with you shortly after the presentation. And at this time, I will pass it off to John Heinz, who is our Vice President of Strategic Accounts here at EnergyCAP, who will be leading today's webinar. John?
Yes, hello everyone. Very much a pleasure to be presenting today. This is a topic I'm really excited about, and I appreciate all of your attendance and interest in this topic. So today we're going to be talking about the real-time energy analytics that we provide in our platform. The mission for EnergyCAP is to provide value out of your energy information. And for those of you that have tracked EnergyCAP over the decades, we have really started our application. It's been foundational in utility bill information. Why is that? Well, because utility bills are easy to get, widely used, the low-hanging fruit of data that you can track. And then we've provided tools over the years for energy sustainability and accounting functions to give you value out of that valuable information. So that has been our mission, with the main driver of getting value out of the data that you have. What we have learned over the years is now that smart meters are becoming widely used, adopted, and installed on a lot of buildings and within spaces, the Internet of Things is really large business these days, where everything is connected, and so the getting access to devices, to systems is becoming easier. There's a higher level of expectation to connect to those devices to get value out of that data. So in order to keep up with the demands of the industry and the demands of all of you, we have taken a large leap forward into the real-time analytics space. What we did was we went out and acquired best-in-class solution in the real-time energy management, analytics, and analysis space. It's a company called Wattics, and we're very excited about this partnership. We're excited to have the team members that are have been part of Wattics for over 10 years, now under the EnergyCAP umbrella and part of the EnergyCAP family. Wattics is based in Dublin, Ireland. I mentioned they've been in the real-time analytics space for over 10 years. Their business that they've built up is to capture real-time interval data from available sources and to give that data life and to provide value from that data. So really, it's a great complement for what EnergyCAP has done for decades, taking bill data and now going more granular within buildings and looking at equipment and spaces and providing a lot of value on that data. So it's really a milestone leap forward for technology for us, and the focus is now shifting from monthly tracking to real-time tracking, more granular tracking of data. So if you're newer to interval data, I'm sure the concept is not that new, but For some of you, you might be asking, really, what is the value of interval data? I get bill data. I understand that. I get a bill from a utility company. I need to pay it. I need to look at it. It provides monthly usage and demand data. So what can interval data, so this would be 5-minute, 15-minute, 30-minute, whatever granular interval various devices provide pulse readings for, it's those kind of intervals. So what can it do for you, and what's the value? It allows you really to drive savings by quickly spotting facility and equipment management problems. So it's your ears and eyes working 24/7 to help monitor your usage. It's the most effective tool to bring bottom line net positive value to your organization. Think of it this way. A utility bill is a snapshot once a month. Interval data is the heartbeat of a device or a building that you can look at in real time to make actions and respond immediately, so you can drive savings for any type of issues, because you can be alerted immediately of potential problems, cut off the problems, and so it doesn't persist for the remainder of the month. You don't get that granularity with the utility bill. So incredibly valuable, so you can take action immediately. You can use interval data to spot a lot of different issues and address a lot of different problems. Equipment cycling on and off, early startup schedules, too late setback schedules, costly peak demand issues. So if you look at your utility bill and you see high peak demand charges on a bill, it doesn't tell you when that happened or what was the factor, what was driving that peak demand. You just know that your rate included penalties for demand peaks. And so having interval data allows you to pinpoint time of day, what device in particular, and what was driving that issue on your bill. Inefficient, custodial crew workflow, weekend and holiday savings opportunities, and utility theft, and really just a whole bunch more. One of the stories that I love the most recently, which we can all understand and appreciate, was during the COVID shutdown, when it was in March a few years ago, when basically all buildings shut down and we all went into our basements and didn't come out for a while. We had a few of our school district clients where they, set their buildings to deep setbacks during those weeks where the schools were closed and everyone was at home. And then what ended up happening was everyone thought it was going to be down for 2 weeks. Like, it's a 2 weeks, and then we'll go back to schools and everything will be operational again. And so one of our clients in particular set all their schools across their district, a fairly large district, for a 2-week setback. And then, as COVID wore on, buildings started to turn back on again with no occupancy and no one in them. And if it wasn't for the interval data alerting them, like, hey, buildings are turning back on, the startup schedule's starting again in these buildings, they would not have been able to address that issue, and the buildings would have just been on because no one was around to see that they were on. And then they would have been, they would have seen the results on their utility bill, and they would have thought that they had setbacks, but little had they known that it was only a 2-week setback. So just showing some of the value of having interval data. I do want to point out the chart to the right, and let me talk about this. So there was a study that Lawrence Berkeley National Labs put out. They actually put it out for the U.S. Department of Energy in October of 2020. And the whole point of the study was to do a bunch of research and polling of a number of organizations that utilize energy management information systems and fault detection systems. And what they wanted to do was go to the U.S. Department of Energy and just say, like, what really is the value in having these kind of systems? What's the payback period? How much can we expect from a cost savings? What this chart is showing is, of that study, what are the main measures that were implemented? Like, what were the most popular measures implemented based on having the interval data to track various projects and retrofits or behavior changes and things like that. So I just found it really interesting looking at that study, so we can see, just of all of you that are on, that would be paying attention to this webinar, of your peers, what have they done to help drive savings? So, a lot of different activities on this list, improving scheduling, changing HVAC settings, just alone, you can see a number of them are just scheduling. So this isn't even going out and purchasing new equipment. And some of these are purchasing equipment. Just changing scheduling has a big return on investment. And that's something you can pretty much do today, but you need the ability to monitor it. You need to monitor what the schedule is today, what like a heat map is, where your largest volume of consumption is. Are your systems actively turning off and setting back deep enough, during off-peak times, so on and so forth. So just really interesting to see all the different areas that organizations are seeing savings and what they're monitoring. Now, sticking with that same study, of the organizations, they, all of them have seen and experienced savings of some sort. And so really over an 8-year period, what the study found was not every organization stuck with an energy management platform, but the initial payback period for across the board for all organizations studied, there was an initial savings in the first 2-year. Basically, you recovered the investment that you invested by purchasing a system and getting all your devices and everything connected. So payback was within 2 years, and then there was percent savings every year thereafter, ranging from up to 17%, down to 4% on average. So implementing these types of systems, really are helping to drive additional savings that you probably aren't realizing as much with utility bills, because this allows you to go deeper and make all these changes, pinpoint the exact causes of high usage and high demand spikes within your building, so you can pinpoint and address the issues. So let's talk very specifically about the platform. So the Wattics platform, really a fantastic system. I'm going to provide a demo, but there's 3 main areas that Wattics helps to address. So the first one is capturing real-time data from existing devices, sources of data, really anything that that's connected to systems that are consuming energy. The data can be captured and imported and brought into the system. Then it monitors. And what do we mean by monitoring? Well, it's tracking data quality. It's providing alarms and alerting. It's monitoring what data is coming in and letting you know if there's any types of anomalies in the data that's coming in. Really helpful when it's in real time, so you can stop problems that would show up on a bill later on. And then lastly, analyzing. A lot of different capabilities to analyze and report on all that rich data that's coming in. Some very specific features that are in the system, the connection to devices, sensors, and gateways. So basically, as long as a device is tracking pulse readings, there's ways to connect to those devices and get that data into the system. For some of you that don't have smart devices installed, we can also make recommendations. So we are a reseller of various hardware that's out there. Depending on what you want to monitor, we can make some recommendations. So these devices you can install, connect to various points within a building, various pieces of equipment, and then that data can flow into the system for tracking. It can track power quality. It provides real-time alerts and alarms. There's machine learning capabilities within the platform that takes historical data, creates an expected profile, and then can alarm based on how you're performing to that machine learned expected profile. There's compliance and adherence to ISO 50001 measurement and verification of savings, KPI tracking. So you can track other variables within the system like production or occupancy or other factors that you want to track and compare and see, are these related, to my consumption? If so, how much? And let's keep our eye on, how these different variables trend against one another. There's heat mapping capabilities and the ability to create formula calculations. Indoor air quality monitoring, which is becoming a lot more important these days with changes in some of the HVAC units and air handlers and some of those types of devices and pieces of equipment where you need to let more air in, fresh air into buildings. So there's air quality monitoring. There's a tariff engine. So as interval data is coming in, you can apply it to a tariff engine and then get your cost for consumption in real time, based on complex tariffs and rates. There's dashboarding and actions tracking and the ability to track notes and remarks as you're looking at your data and analyzing it. If you want to tag users so they can take a look at the data. Scheduling optimization. The one chart I showed earlier, numbers of organizations are getting deep savings just by changing scheduling. So there's some tools to track in the platform. Let's look at your consumption, and then you can start tracking. Like let's change some scheduling based on the piece of equipment or the zone in the building, and let's see what our savings would be if we change some of the scheduling for when machines are, or equipment are turning on and turning off. You can track production and then load shapes and profiling. A lot of different capabilities that are in the system that we will cover today. A very important piece is to understand all the integrations that the platform can do to devices and systems that are out there. There's a number of existing integrations, and we have documentation for existing systems and devices and gateways and sensors that the platform already has integrations and connectivity to. Our documentation also provides the details of how to get connected to devices. So it's going beyond just saying, what can we connect to, but also how do we connect to it? And so if any of you are using the platform, you could go to those devices, either install them, or if you have them installed, there's documentations just how to get them configured and get data flowing directly into the system. Many of you watching this webinar already have meters or devices in place and installed within your buildings. And that's fine, and that's great. So if you have a data historian or systems that are collecting all of connected to your devices and grabbing data and storing it into a database, we can connect to those databases. That data can then be flowed into the system through API exchanges or file exchanges, various ways to connect to existing systems and databases that are collecting data within your buildings. We can connect to, gateways and really any type of device that can transmit the data through an internet connection or other method. Our team every day is working on integrating to new systems and to new devices with clients. So a lot already exists. Doesn't mean that we can't exist to anything that you throw at us. We're always happy to talk about an integration and build new ones. Okay, let's dive into the product. Real excited to show this. So this is the platform. I'm going to start by talking about the data that's coming in. So let's go straight there. So the Wattics platform as I went through, is connected to various systems, databases, file exchanges, devices, gateways, really anything that's tracking pulse readings that we can connect to and then bringing in the data. So the way that the system is set up is over to the left, there's a tree view, which is where you set out a hierarchy, and structure a hierarchy of your organization. This allows you to set up organizations, buildings, and then the points that you are tracking, whether it's a zone in a building, or if it's actual components of a chiller, or potentially components of an HVAC system or refrigeration, or if it's a gas main or a water main, or if it's air quality sensors, whatever it is, all these different points, devices, sensors get tracked to a building, and then there's this hierarchy. So you can report at any level and compare data at any level within the hierarchy. Throughout the application, in the middle of the screen are the analytics. So the analytics, the reports, the charts of everything that you want to report on. And then over to the right are filters. So these are showing how you want to filter this data over time. So in this case, this examples of a hotel. I'm just clicked on the bar area of a hotel. So this is a zone within a building, and then we're looking at just the interval data that's coming into the system, that the system's connected to. So over to the right, I can really click on any time period. For instance, if I wanted to kind of go up to today, I can see what the profile looks like even today as data's coming in. So all I'm doing is clicking to the right. If I wanted to, let's say on Halloween, I wanted to see what my profile looked like, I can click on October 31st, and here I can see what the profile looked like for this meter, for this tracked point within the building over time. You'll notice over to the right as well, outside of date filters, there's the ability to look at different channels within the device that is monitoring the electricity for this zone in the building. So what I'm looking at here is KW, but I can go and look at other factors. For instance, if I wanted to monitor my power factor and see what that looks like, I can look at voltage, or I could also look at current. Really, it depends on what your device, what type of device you have installed and what all it's monitoring. But this allows you to bring in different channels within a meter that is monitoring, currents and pulses within your electric consumption, and then bring that in for analytics. So, again, this is just profiling the raw data that's coming in so I can look at it over time. Here, if I wanted to look at, say, the 15-minute average demand for a given time period, I'm looking at daily. It'll find the 15-minute average. I can also look at the 30-minute average to say over a 30-minute span, where was my peak at? The data that's coming in for this meter is in 5-minute intervals. So this is an example of a device that's connected, that's reading pulses every 5 minutes and then transmitting it into the system. Let's say I wanted to look at this on a weekly basis. I could go to my weekly chart and then see how I'm performing week to week. And again, I want to look at my peak average over that week period. So that's what it's finding for me and giving me what the value is.
John, I don't want to interrupt you, but we got a good question that might fit in here.
Sure.
Question about, can we filter data by weekdays?
In this case, we're just looking at a weekly trend.
Got it.
So in this case, it's just the week. But that is a good question. There's other parts that you can look at, specific days of the week. But here we're just looking at raw data. So, but I understand that, right? Because if you're, say a municipal buildings, or your higher ed or K-12, we have a lot of different clients that are, pretty typically Monday through Friday operations. then you would want to like look at weekends differently. I certainly understand that, and there's ways to look at it. This is looking at the raw data. Let's say in this case, I wanted to drill into a very specific time period. I can just drag that and then drill into that time period. So you'll notice throughout the application, the charting tools allow you to drill into data real easily. The other capability with all the charting within the application is the ability to download images for if you want to paste images into a PowerPoint or other presentation. You can also very easily download the Excel data that backs whatever chart you're looking at. So whenever you build the chart, and you'll see more of this as I progress through the system, as you filter the data and you go in and you want to analyze data in any given way, you can just export that raw data for whatever you're looking at and then look at it in Excel. Okay, so as this data is flowing into the system, there's alarming that gets activated for that data to spot problems automatically for you. So let's talk about alarming and alerting capabilities. And there's really three different types of alarms. The first one is just an offline notification. Now, why is this important? Well, if you have devices connected and data's, and you're having the data flow into the system, well, what happens if, say, the internet drops within a building and a gateway can't communicate out, or the system just for the last day has not received any readings? Well, that becomes a problem on a lot of levels. First off, it's going to mess up all your reporting and analytics, but more importantly, if a meter goes offline and you're monitoring it, say for a demand response type program, or you want to spot leaks, for water or anything like that, the system, it starts to learn the behavior of how often the intervals are coming in, every 5 minutes, every 50 minutes. But so you can set up notifications to trigger on any given meter if data is not coming in. So you could say, look, if I don't get data over a 1 hour period and I'm expecting it every 5 minutes, then send me a notification that my meter's offline. That then would trigger a response, hopefully within your organization, to have someone go take a look and see what's going on. Get the meter back online so data can flow again. So that's one type of notification. It's just alerting your team if a meter is offline. The second one is, the second set of notifications are customized detections. These allow you to go to any meter and you establish what the, what channel you want to set an alert on and what the threshold and condition needs to be. So you're basically telling the system if a reading meets this condition, either like it's above this threshold or below, or whatever that is, then send an alarm, send an alert. So here is where that question that Amber had asked, this is the, possibly where you'd want to start looking. You might want to set up some custom detections just for the weekends. Because if your buildings are supposed to be set back on the weekends, you can set up custom detections just for Saturday and Sunday to say, look, if my buildings seem to be turning on or if they're peaking out at certain points, then notify me so I can get someone down there immediately to shut down the building. So this is, a really useful way of setting up your own configuration depending on what the meter is and what the building is, of how you want to get alerted. So you set the thresholds and then you can tell the system, do you want to be notified on dashboards? Do you want to get notifications through text messaging or through emails? Who all needs to be on the email or text communications? So you can tell the system, who do you want to send these to? And maybe these weekend notifications, you want text for those, but emails for some of the other ones because you don't want to be disrupted during the workday as much. So you tell the system how you want to be alerted. So those are all customized detections. And then the last set of detections is based on what's called Sentinel views. The idea with Sentinel is you have a meter, or a monitored point, I should say. It doesn't always have to be a meter. You have a monitored point that over time, the system learns the trends. And so it's learning based on the day of the week, the general use and profile for this point. And then it builds an expected load for that point. So in this case, for today, the system created an expected load, which is in green. And the reason it's a wider variation is because just over time, it's giving some allowance. It's saying we're generally within these ranges. It's pretty common to be in these ranges over the history of all the data we've been tracking. And given it's a Thursday, like this is an expected profile. So this is creating that expected profile, which is green, and then the black is the actual load for the day. This meter is located in Europe, and so that's why we haven't completed the day, but it's later on in the day, at least compared to me on the East Coast here. So it's saying throughout the day we actually went below the Sentinel in a couple time periods, and then we spiked above in one of these time periods. So this is valuable to see. So the actual load was close to the expected, but it did peak out at like this time when normally that's set back deeper. So you can have alarms notify you when the Sentinel, when the actual goes above or below the Sentinel. So let me show you what that looks like. So if I go to a home screen, this is where alarms and notifications can be shown to you. So I can get a text, an email, but I can also see them here on a home screen. So these are all events that have triggered an alarm in the system. So let's take a look at this top one. This is saying an AHU, which is an air handler unit, has consumed 261% more than usual during this time. So it's well above my Sentinel. It's in this building. It's costing me €3, and it's a problem. I should take a look. So down below here, I could say, well, let me go analyze that. Let me take a look at this on my Sentinel view. So here's the Sentinel profile, but you can see there's a lot of variability today, or I guess this was 2 days ago. And then here's where the notification hit, because it spiked well above, outside of my range. And so it's basically telling me my air handler unit just started turning on well before when I would normally expect it to be engaged in a normal day. So basically things started to turn on in the building, 5:30 in the morning when it normally starts turning on at 7 in the morning. So this is a good example of maybe the schedule got out of line recently. And so I want to go take a look at the HVAC unit and see what's going on there. So that's kind of an example of how these notifications are displaying and what all it's telling you. It's giving you more details than just, a notification was set up. We're actually also applying the costing to it. So, how much this potentially is costing you because it's outside the expected load. Okay, so what else can the system do? So let's take a look. So now we have good data in the system, data's flowing, we've been alarmed, and alerted to problems. And so now we want to look at data more granularly. So let's just kind of stay with this HVAC example. So an HVAC system has subcomponents that make up the HVAC. So these are all being monitored and those points are being brought into the system. So using this charting tool, I can click on any point and just look at various trends. So here I could say, let's maybe say on a monthly basis for the month of October, What was my total use? Well, my total use for HVAC, the HVAC activity, 67,000 kilowatt hours. So that's for the month. I can look at this then on a daily basis. So daily, each day, I'm using a little bit more each day. These are probably weekdays. If we go back and look at it, the actual days of the week, and these are probably weekends. I'm just guessing here based on, normal activity. Actually, it says it right here, Saturday and Sunday. So, so you can just see what the profile looks like for the month. But let's say me as the engineer, I want to see how do all these components stack up to the actual activity of HVAC. So I'm looking at HVAC as a whole. I can look at this a lot of different ways, maybe on a line chart, a bar chart. I'm looking at it on a monthly basis. Maybe I want to look at it on a weekly basis. Maybe I want to compare 2 weeks with one another. So I could over here click compare. So now I'm just showing 1 week on top of another week. You could look at it daily views. So this is 1 week, compared to another, or I'm sorry, 1 day compared to another. Let me say if that was a Monday, let's go Monday to Monday. So August 31st and November 14th. So just what the 2 days, one on top of the other, look like. So a lot of ways just to look at the data, drill into it. I'm looking at it on a 5-minute basis. Maybe I want to look at it rolled up to hourly intervals. So whatever you decide, you can choose. But let's say me as an engineer, as an operator, I want to say, well, how do all these compare to the total activity? So what I can do is I can just start clicking these and maybe remove the HVAC so we don't double count here. And what this tool will now start to do, it'll start overlaying all of these components one on top of the other for whatever time period I'm selecting. So let's say I want to look at on a monthly basis, how do they all compare? So here I can look at my air compressor and how it compares to my chiller. I can tell you by this, my air compressor and my chiller are the main energy drivers for HVAC. So I can, at least come up with that conclusion pretty quickly. You could look at this a couple different ways. I could compare all of this side by side. I could also then say, well, let's stack all these one on top of the other so I can see, what my total is for HVAC, which this looked like the chart that I just showed. But what this is doing is breaking it up to, of the HVAC activity, what are all the subcomponents that are consuming to make up the total. So really nice charting tools to allow you to compare meters with one another. I can go to different points in different buildings too. I could say, let me go to this point in this building, and let me go to this point in this building, and just compare those 2 points with one another. So you pick and choose what you want to compare, and then the charts will update, based on what you're selecting. There's some overlays you can put on the charts. Like you can add, let's see. Let's say I'm just looking at this area. I can overlay an average. So maybe I want to see the average consumption. Let's also, maybe I want to look at weather. How's weather affecting my consumption? So I can click on, the tabs over here, depending on where you're located, if you want Celsius or Fahrenheit. I can also overlay weather data on top of here. So you can see what the mean daily temperature is in this case, because we're looking at, daily profiles. So, we can overlay other variables on these charts as well. Anytime you build one of these charts, and there's a lot of these, user defined, you define how you want to look at the data and save it. Anytime you like a view, you can save it. So I could say, I really like this view. I'm going to call it John's favorite. And let's say I always want to look at this. I just really like this. I might say I want to look at it on a rolling time period. So I can select the time period. I might say, hey, I also want to share this with Adam Wetzel. Adam Wetzel is another team member here. Maybe Adam also would find use in this. And maybe Amber would. Amber's on this webinar. Maybe Amber wants to see this. So I can say, well, let me share this with those team members. And now this is saving to my favorites dashboard. So here I have a favorites dashboard. So I've already pre-selected a lot of widgets. If you look down to the bottom left, this is the widget I just saved. So I just saved this. I can scroll through time periods and look at different time periods using these arrows for any of these widgets that I've saved. You can download the data, right? Like download the data of these charts. You can look at it in a couple different ways. You can also grab a URL of the data and then share this with others. So now that I've created this dashboard view, I can share it with other team members or just bookmark it or embed it on a website. So those of you that are maybe familiar with EnergyCAP dashboarding capabilities, this has some of the same where you build your views, whatever you want it to look like, you can save it, and then you get a URL which you can embed or share with others. So some really great sharing capabilities with all of this real-time data coming in. So what else can you do? Well, we talked about monitored points. So all of the data that I was showing are data points that are coming in from sensors, devices, from systems. Other types of data you can track are like production or hours of operation or widgets produced or other types of variables. And what you can do with that data is there's a formula calculator, so you can create formulas, so you can create virtual points. So you can, like, let's say I want to add these 2 points and use that as a virtual point for analysis. You can do that in the system. Maybe I want to compare my usage. So let's say I want to compare my HVAC operation. So I can, find my HVAC operation point. And maybe I want to see how that compares to production. Or, in some of your cases, occupancy. If you have that occupancy or production data, you can bring it into the system. And then what you can do is you can run comparisons like this, where I just pick these 2 points. It runs a regression. It tells me how strong the correlation is of these 2 variables. So how strong is my HVAC usage correlated to with the production going on in a facility? And it's telling me that, it's a fairly strong correlation and what all the variables are. So you can create these formulas on the fly to do these types of comparisons and analysis. So some really nice advanced capabilities to do some statistical modeling, to run comparisons. Okay, a lot of what we've talked about is consumption. Let's talk about cost and greenhouse gas, because that it can be tracked as well. So within the system, there's a tariff engine. This allowed you to build time of use tariffs, where you can build out the rate schedule based on the rate schedule that you're being billed. You can also enter your own CO2 factors. So you can control what your emission factors you want to apply to your consumption are. You can also build rates. You can build simple rates or complex time of use rates, depending on day of the week and on-peak, off-peak time periods. So you can build all of those using this tariff engine. The tariff engine does let you run what ifs. So once you have a tariff built, you can run a what if. What if I change to this rate? Let me model that. And then you can run to see, based on the interval data and your current rate, had you been on that rate, what your cost would have been. So you can use it for rate modeling like that, but you can also use it, even just in a very simple form to apply against your consumption. So let me go back to some of these views we were looking at. So here, if I go back to the bar area and we have our trend chart, so this is looking just at, daily usage, I can over to the right say, well, instead of usage, let's look at cost. So now that I have applied a tariff or a rate, I can look at the cost. So for this point of electricity, for this day, we spent $50 on electricity. I can also look at my CO2 emissions. So I know that I've emitted 48 kilograms of CO2 emissions into the air based on my consumption. So this entire platform is not just tracking consumption and demand, it's also looking at your cost and CO2 emissions as well. So you can use all of those views I just showed. Instead of looking at use, look at cost and CO2. Another noteworthy item is if you have an area on the chart, and let's say you want to add a remark, I can right here say, hey, I want to tag this. I'm going to tag Amber and say maybe she needs to, maybe I want her to look at a specific reading on a date or time. So I could say, hey, Amber, go, let me make a note to advise her to come in and to look at the readings between these time periods, just because I want her to look at something. Really helpful if you have a demand spike or a system, that seems to be on when it shouldn't be on. So you can notify users, and then you can overlay those notifications on these charts to show the time period of when you set up those various remarks. So that's a good, call it a work order to notify users that they need to log in and look at something. All right, a couple other capabilities. One is a heat map. So let's look at this bar area. I don't know why. I guess I got a bar on my mind. It is Thursday. We're nearing the weekend. So we're looking at a bar area in this hotel. So this is a heat map. So it's showing for the month of October the usage profile. So the dark bars, the dark squares represent the high consumption time periods. And the lighter represent less intense, lower usage time periods. So this is really helpful. So I can see, this is a bar area in a hotel that the systems are turning on at like 4:30 or 5 in the morning. I don't know about all of you, but I don't know what bar is opening and systems are turning on that early in the morning. So what this is telling me is there's a potential scheduling problem in this space where systems are turning on really early in the morning, and then turning off or starting to dial things back near noon. So this at least gives me a good idea where the majority of the consumption is taking place. There's then a schedule optimization tool, and as we learned earlier, that schedule optimization can be some low-hanging fruit to really drive savings. This tool lets you look at your heat map. Let me go back to October. So this is that heat map we were just looking at. And what I can do is I can then come over here and say, well, what if I had deeper setback, let's say during, night hours. So maybe I can get some deeper setback during night hours, and maybe I can't reduce my consumption 100%, like completely shut down systems. But let's say I shut them down 70%. So the question is, if I do that and I can shut down during general off-peak times, how much can I save in any given month? So I can save this schedule, and it'll change my heat map. So it'll say, well, now we're going to change it to look something more like this. I can then see, well, what would my usage avoided be? How much would I avoid using? And I can apply cost to it. So I would have saved in October $511, or 30% of my total monthly cost, had I been able to change the setback schedule to maybe something more reasonable, given it's a bar, and you don't need it to operate that strongly in the morning hours. So that's a very useful tool. So you can run some what ifs by changing some scheduling. Now, let's say you're implementing projects and you want to track the savings due to projects. So you got this. Now you're saying, I now want to make some actual changes. There's a measurement and verification of savings tool. This tool adheres to both IPMVP option B and option C protocols. So this allows you to track whole building savings, but also isolate a specific point, monitor it, and then report the savings. So let's walk through an example. So let's go, this is a manufacturing building. And within this building, there was a project that was implemented on a piece of equipment, okay? So this tool lets us define the project. So what is it? Well, this production facility produces potato chips, and they made a change to one of their pieces of equipment. So here we can list what the project is, and step 2, list what the energy conservation measure is. So what are you going to be doing within the building? You then establish a base period. So what is the monitored base period using interval data that you want to use and compare against? And then what is the reporting period? When do you want to start tracking your savings? You can make adjustments to the equation and then create a model. So this is doing a multivariable regression model where it's taking into account degree days and production. And then building, is there a relationship? Is there a correlation of my consumption with both production and heating degree days? If so, how much? And then we know how much to adjust the calculation. And then we can calculate our savings. So this is saying this is the model prior to the project. And then, well, the green is the measured, and then the red is the model. So this would be, the red is the predicted value had you not done the energy conservation measure, and the green is your actual measured consumption. So it's telling you, showing you visually what the delta is. And then down below saying, what did you save per year? You can apply cost. In this case, it's in euros, so 10,000 euros. And it's saying our payback period based on the cost of the project and the savings per year is about a 1.5 year payback period. So very nice tool to track M&V. Okay, that's all of the demonstration. Let me round out this webinar with a few more slides. So hopefully that was informative, and hopefully I got you excited about the application. I think it's fantastic. I think it's very necessary. Obvious question, what does it cost? So we want to be real transparent about costs. There is an annual subscription fee, and it's based on a couple criteria. There's a platform fee of $4,200 a year to get access to the Wattics platform, to get access to upgrades, to get access to customer success and our support teams and all of our documentation. There's an add-on module to track air quality. So, and then beyond the platform and air quality fee, we then charge per point. So it all depends on how many points you need to track in all of your buildings. You can start with 5 points. You can track as many as you want, tens of thousands of points. Just depends. The standard rate to track a standard point is $20 to $38 a year. And then a complex point would mainly apply for electricity if you need to track power quality and a bunch of variables. The cost to track those points is a bit higher because more data is coming in. There are one-time services. These really just depend if we need to create brand new integrations to systems. We have a whole library of existing plugins and systems. So if you currently have those, then there's no one-time fee. You just pay the annual fee and we get started and connected immediately. We can also recommend hardware, so meters, gateways, sensors, and fees range really depend on what you need. So those are the fees. We do want to offer an incentive to be an early adopter of the Wattics platform here in North America. We are offering for a limited time 50% off all of your first year fees if you purchase by December 31st. So before the new year, if you can get a budget together and we can work it out, 50% off all first year fees. So happy to extend a discount for all of you attending this webinar. I hope this was informative. Please email us at sales@energycap.com. If you want to get a pricing quote, email that email address with the subject line Wattics special offer to make sure that we receive that immediately and get back to you very, very quickly. Thank you for attending. I will now see if there's questions with the remaining time we have.
We have so many questions, over 20 questions rolled in. There's no way we're going to get to all of them, you guys, but we will follow up with you personally for those of you who we can't get to. We got one really good question from an anonymous attendee that says, I see some similarities between EnergyCAP and Wattics. Will Wattics be accessible through EnergyCAP, or is it a completely separate platform?
That's an absolute great question. Yes, we are making integrations within both platforms where you can jump from one application to the other, and we can share data. So for some users, you want to get your meter data into Wattics so you can do advanced analytics, but you also need that to flow to EnergyCAP for billing purposes and other analysis within EnergyCAP from a monthly standpoint. So yes, you will be able to use single sign-on to log into both platforms, can toggle back and forth, and then share data.
Great. Similar question from our friend Sean Finnegan is, can you pull Wattics data into Report Designer Power BI?
No, it's a different database as of now. Wattics is built on an API infrastructure similar to EnergyCAP, and really RDBI was built on the APIs. So over time, possibly, but not right now. RDBI doesn't look at the Wattics database.
Another question's around Sentinel. How much history do you need in the application for Sentinel to be valid and useful?
That's a great question, and I might need to look up the answer. I want to say I believe it's 3 to 6 months. We can follow back up on that one. But it does need to be over time because it is looking at days of the week, seasonality. I don't know the exact time period offhand.
We got another interesting question: is can the data in Wattics be used to generate work orders?
Yeah, absolutely. I mean, conceivably, yes. I don't know if anyone's doing it today. I would need to talk to the Wattics team members, but the remarks part that I showed, all of those are objects in the database, and there's APIs. And so depending on, if the question is you have asset works or a maintenance work order system or just whatever it is, and you want, to like trigger an event, one of these alerts or the remarks or one of those to go to the work order system, it could be developed. To my knowledge today, we're not, that's not happening, but, it's definitely conceivable that could happen.
Mm-hmm. Another data integration question: can Wattics connect to our SQL database where we already have our interval data going into EnergyCAP?
Yeah, the answer is yes on that. It integrates databases like that all the time.
Great. I think we've got time for one more. This is probably a specific question to something you were showing. Where does the cost savings data come from? From estimated billing costs or from specific billing information in EnergyCAP?
No, the cost savings is from the rate. So you apply the rate to the interval data. And so then it's looking, I'm guessing this is probably one of our users that's using cost avoidance within EnergyCAP. And so they're looking at this. So what this is doing is this is showing what the usage, in total is over the reporting period. So this would be base period. This is post-base reporting period. And so it's calculating what the total kWh is over this time period, which is shown below. And then this cost is the rate that I was showing earlier that you build into the Wattics platform that's saying what is your cost per kilowatt hour. But if it's a more complex rate, it's looking at, at day of the week, time of day, things like that. But you could use a simple unit cost and not build out a more complex rate if you wanted to. But really that's where that's coming from. It's coming from the rate applied against this usage over this time period.
Yep. Great. There's many more questions. They keep rolling in, but I'm so sorry. We don't have any more time. We will be following up with a link to this recording. And as John mentioned, if you are interested in taking advantage of the special offer, please don't hesitate to email us soon. John's a very busy man and has a busy schedule, and we'll want to get you booked some time with John to do the contracting for that. So act fast. Now's the time. If you can pull that email back up, John, be sure to email us at, I think it's info.
No, sales at EnergyCAP.
Sales at EnergyCAP.com with the subject line Wattics special offer. Thank you so much, John, for presenting today. And thank you all for spending some time with us to learn a little bit more about Wattics.
Thanks, everyone.
Have a great day.
The energy savings. Take care.